So at the moment we can press play and we can move around as our character, but as we can see the character isn't animated. So we're going to start taking our first steps for getting him animated in this lesson. We'll be starting with the basics. Now we already have animation assets for the marine character. We can see this by coming to characters and then coming inside the marine folder and then the animations folder. But how do we tie all these animations together to take into account our player character's movement? Well, we're going to be doing this inside a new type of blueprint we haven't seen yet, called an animation blueprint. And just like it says in the Unreal Engine documentation, an animation blueprint is a specialized blueprint that controls the animation of a skeletal mesh. So this is what we're going to be using to start putting together some logic behind these animations. Let's create the animation blueprint inside the folder where we have our animations. We're going to right click in the content browser and then come to animation and then the animation blueprint just here. Now when we do this, this window pops up and it has two sections. We don't need to worry about the top section of this window as it's not relevant to us at this stage. We just want to focus on this bottom half. It tells us to choose a target skeleton, which is going to be our marine skeleton here. So we just select the marine skeleton and then we can hit OK, and now we can name our animation blueprint asset in the content browser. So we can just name this something along the lines of anim bp underscore marine. Okay, so that's our animation blueprint asset created. Now let's double click on it to take our first look at it. Okay, so here we go. Straight away we can see a preview of our character on the left. This is going to update in response to the logic that we set up in our animation blueprint. Now the main thing to understand about animation blueprints is that you have these two tabs that kind of work like different contexts you work in. You have the anim graph and then you have the event graph. The anim graph is all about setting up animation state machines. This is where we'll be setting up the states such as the character being in an idle state or a running state, and the animation will switch depending on the state. The event graph is used for storing and updating variables that can then be used within the anim graph to drive the behavior of the state machines. But let's not get too lost at the moment. Let's start real simple by focusing on the anim graph. How do we get our character animating? He's currently in this static pose at the moment. Well, we see this big final animation result node, and it has this result connection to it in the form of this character icon. As there is nothing connected to the result, our character is stuck in his base pose. Now all those animation assets we saw can be used in this anim graph. If we look towards the bottom right corner of the interface, we can see this asset browser tab. Here we can see all the animations available for us that we can use in our anim graph. Let's click and drag out the idle animation onto the graph. And here we can see it's added a node for our animation, and it has this little character animation pose output pin. Now we can actually click and drag this and link it to the result of our final animation pose. Now it looks like nothing's happened, but take a look what happens when we hit compile. Our character is now in his idle animation. So this is a good first step for us. What happens now if we come back to our level and hit play? Well, we can see that the character is still in his base pose, even though we've just set up our animation blueprint, so he's in his idle animation. This is because our animation blueprint is not yet assigned to the mesh component of our marine character blueprint. So I want you to pause here and open up your marine blueprint and try find where you can assign the animation blueprint. Then assign it and hit play again, and you should see your character in his idle animation. Okay, so to assign our animation blueprint to our character mesh, we can select the mesh or select the mesh component, and on the details panel we can see that we have this animation section. We can drop down the anim class here and we can select our anim BP marine, and notice that the animation mode is set to use animation blueprint. We can switch this to use animation assets, so we can force the character into a particular animation, but we're going to use our animation blueprint here. And we can see our character is now animating already, and we can hit compile and save. And now when we hit play in the game, we can see he stood in his idle pose. Okay, great, but now when we move, he's still in his idle pose. So let's come back to our animation blueprint to take a look at how we can add some more animations. Now what happens if we want to have more than one animation? Well, this is where we want to start using a state machine. A state machine allows our animations to be broken up into user-defined states. We determine which state to go into with transition rules. For example, our character would only be in an idle state when he isn't moving. So the transition rule would check to see if the character's speed is equal to 0. When the character is moving throughout the world, we should be in the running state. So the running state would have a transition rule that would check to see if the character's speed is above 0. So let's take a look at how we can create a state machine in our anim graph. Let's start by deleting our idle animation. And if we right click, we can type into the search bar here, new state machine. So we can add a new state machine. Now when we select the state machine, we can add a name for it. We can just call this locomotion. This state machine is going to handle the locomotion of the character, so the idle and the running states. We can connect the animation pose from the state machine to the result of the final animation pose. But notice what happens here if we hit compile. Our character goes back into his base pose. This is because the state machine has no states within it and no animations inside of it. Let's double click on the state machine to enter it. Now we want to set up two states, one for our idle state that will contain the idle animation, and one for our running state that will contain the running animation. To add a new state, we can drag out from this entry node here and we can release. Then we can select add new state. Now we can name the state. Our first state that we start with should be the idle state, so let's just name this idle. Now how do we assign the animation that the idle state has? Well, we can just double click on the idle state to enter it, and then we can drag and drop the animation in here just like before, and we can hook it up to the final pose for the state. Now let's come back to our state machine by coming up to this top bar and hitting the name of the state machine, or we can hit this back arrow towards the top left. Now let's add another state. To do this, we can drag out from the idle state, and we can do the same thing as before. We can select add new state, and then we can name it, and this state is going to be our running state. So let's just name this running. And let's enter this state so we can assign the running animation. We're just going to use this run forward animation here. So let's make sure that we hook it up. Okay, and if we come back to our state machine again, we can see now that we have our idle state and our running state. And we also have this arrow connecting both of these states together. This is currently telling us that we can go from the idle state to the running state, but it's all based on the transition rule, which is why we have this little circle icon here. This is where we would set up the transition rule, but we can't really do anything with this yet because we need to work with some variables. And remember, we store and update variables within the event graph. So we're going to wrap this lesson here. In the next lesson, we're going to be working with the event graph so we can store and update some variables, so we can set up our transition rules for the state machine. So once you're ready, we'll be tackling this in the next lesson. Okay, so we have a state machine in our animation blueprint, and we have two states, our idle state and our running state. Now, in order to go from idle to running, we need to set up a transition rule. We need to tell the state machine to only go from idle to running when the player character is moving. But how do we even communicate to the player character to read information such as the character speed? Well, this is where the event graph comes in. In the event graph, we see this event called update animation, and this event will fire every frame. We're going to set up some blueprint code that will execute from this event. We want to calculate the speed of the player character, or more importantly, the pawn for which this animation blueprint is associated with. So how do we do this? Well, if we right click in the graph, we can come to animation, and then if we scroll down a bit, we can find the try get pawn owner function. This function returns a reference to a pawn, specifically the pawn that this animation blueprint is associated with. Now we need to narrow down if this pawn is our marine character blueprint. To do this, we need to look at casting. The character class inherits from a pawn. Then when we create a new blueprint character, we inherit from the character class. However, we could have numerous character classes across our project, and later in this section, we will be building the aliens that attack the player as well. So we're going to have more than one character class. We currently only have a reference to a pawn. It's not a direct reference to our BP Marine character class. However, by casting, we can call properties and functions that relate only to the class that we want to work with. So let's drag out the return value of this function and let's cast it to our BP Marine character class. We can just start typing it out exactly how I say it. So cast to BP, and we can already see it here. So cast to BP Marine. Now let's make sure that we hook up the execution pin of our event blueprint update animation and connect this to the cast. Now we have the output execution pins of the cast node. This first execution pin will execute if the cast was successful. In other words, this pin will execute if the pawn that is associated with this animation blueprint is our BP Marine. So this is good because we will now be able to call properties and functions from our BP Marine character, something that will help us out a lot later. For now, we want to calculate the player speed. In order to do this, we're going to drag out from the return value pin here, which is the reference to the Marine character, and from this we can call a function to get the velocity of the character. And this returns a vector, but if we drag out the vector and call the vector length function from this, we will now have our character speed as a float value. The speed is calculated as unreal units per second, just like the max walk speed on the character movement component. If we were stood idle, this value will be 0, and if we were running, this would be the same as the max walk speed of the character, which is by default 600 unreal units. So what do we want to do with this? Well, we want to promote it to a variable so we can store it and use it within our anim graph so we can drive our state machine. So let's right click on the return value of this function and promote it to a variable. And we can name this movement speed. Now let's just make sure that all our execution pins are hooked up correctly. So the event is hooked up to the cast, and then from the true output of the cast, if it is our marine blueprint, we're going to set our movement speed, and we can just move this set node up here as well and just move these functions just to make it a bit neater. So every frame, we're going to get the pawn owner and make sure it's the marine blueprint, and then if it is, we will store the character's movement speed. And now this is all we need to do in our event graph. Let's switch back over to our anim graph, which at the moment is our state machine actually, and notice that we have our movement speed variable now, and this is perfect because we can now correctly set up our transition rules for the states inside the state machine. Let's double click on this white circle here above the arrow that connects our idle state to the running state. This is where we can set up a condition to allow us to go from our idle state to our running state. This is going to be rather simple to do. To go from idle to running, we want to make sure that the character's speed is over 0. So we can simply drag our movement speed variable off the variables tab onto the graph and we can get it. And if we pull out the pin for the variable, we can then put in the greater than symbol and we can call float greater than float. Now we don't even need to change the value. This is asking a question: is the character movement speed above 0? And the answer to the question is going to be stored in this Boolean return value. And we can plug this straight into the can enter transition result. So the answer to our question will determine if we can go from idle to running. So if the movement speed is above 0, we can now enter the running transition. So let's just hit compile and save to save our work. And if we come back to our level and hit play, we can see that the character is in the idle animation, but as soon as we start running forwards, the character is now in his running animation. But as soon as we stop, we then get stuck in the running animation. So this is because we haven't set up the transition to go from running back to idle. But I want you to do this. Connect the running state to the idle state. This will then create a new transition rule. To transition from running to idle, you want to check if the movement speed is equal to 0. So pause here to set up this second transition rule. Okay, so to set up this transition to go from running back to idle, we first want to drag from the running state back to the idle state and we can connect it so we can create a new transition rule. we can double click on the white circle to set up the transition rule now. To go from running back to idle, we want to get our movement speed variable, and we want to check to see if the movement speed is equal to 0. So we're going to drag out the pin, we can put in the equals symbol, and we can just get a equal float. So is this float equal to 0? The answer to this will determine if we can enter the idle state from the running state. Okay, let's hit compile and save. And let's come back and just look at our state machine. So we can go from idle to running, but we can also go from running back to idle as well. Now if we come back to our level and hit play, we can see we are stood idle. As soon as we start moving forwards, we go into our running animation, and as soon as we stop, we then go back into our idle animation. Awesome, so this is working pretty well, but you'll notice if we run right or left or backwards, we are still in our running forwards animation. But we have other animations for running in different directions. So let's see how we can set those up in the next lesson.